I will be reading the science test. So the first part of the test is all multiple choice. You need to choose the best answer for each question. Number 1. 2 students are pushing on a box. The box does not move. What can be said about the forces being applied by the 2 students? A, the forces are balanced and in the same direction. B, the forces are unbalanced and in the opposite direction. C, the forces are balanced and in the opposite direction. Or D, the forces are unbalanced and in the same direction. Number 2, a student applies enough force to kick a soccer ball. The student's force is shown as an arrow in the diagram below. What direction will the ball move? In an upward direction? In the same direction as the force was applied? C, in the direction opposite from the force that was applied? Or D, in both directions? Number 3. Use the illustration below to answer the question. 2 people are pulling on opposite ends of a long rope. The arrows indicate the strength of the force. What can be said about the forces being applied by the 2 people? So notice the arrows are not the same size. So that indicates the strength. What can be applied? What can be said about the forces being applied by the 2 people? A, the forces are balanced and in the same direction. B, the forces are unbalanced and in the opposite direction. C, the forces are balanced and in the opposite direction. D, the forces are unbalanced and in the same direction. Number 4. Ben was investigating the movement of a vehicle across the table using washers as the pulling force. The chart below shows his observation. So 4 washers, the vehicle did not move, and the speed was 0. 8 washers, the vehicle moved slowly. 8, the speed was 8. 12 washers, the vehicle moved quickly, the speed was 4. 16 washers, the vehicle moved very quickly, speed was 2. Based on the data, which of the following statements explains the pattern between force and motion? A, as the force acting on the vehicle increases, the vehicle moved faster. B, as the force acting on the vehicle decreased, the vehicle moved faster. C, as the force acting on the vehicle increased, the vehicle moved slower. Or D, as the force acting on the vehicle decreased, the vehicle's motion did not change. Number 5. Miss Johnson's class was investigating pendulums with different string lengths. The pendulum picture graph below shows the results for the number of swings in 15 seconds. So at the top of the graph, that's what it says, number of swings in 15 seconds. And then this over here on the left side says length of the string in centimeters. Based on the pattern, how many swings can be predicted for a pendulum that is 25 centimeters long? So if it was 90 centimeters, it took 8 seconds. Or that's how many swings, sorry. If it was 90 centimeters of string, it did 8 swings in 15 seconds. If it was 70, it did 9 swings. If it was, the string was 40, it did 12. So just look carefully at the graph, each part of the graph. So some of them are right on the line. So this one is kind of in between 30 and 40. So it's kind of almost like 35. This one, so like about the length of the string was about 35 and it did 13 swings. If the length of the string was almost 30, right at 30, it was 40 swings. If the length of the string was a little bit longer than 20, so it's a little bit down from the 20, so like 21 maybe, then it did 16 swings. If the length of the string was right at 20, it did 17 swings. And then way down here was the length of the string was about, it's in between the 10 and the 20, so probably roughly 15 or 16 because it looks a little bit longer than halfway. Then it was 19 swings. So the question wants to know if the pendulum was 25 centimeters